Today we're going to do an A6 pop test. We'll see how well this does. You could basically sweep through a lot of years on the kind of questions you answer. And I try to keep it fairly basic, so you don't drift too far off into the weeds. I'm in this engaged in this ASE renewal app, and it's basically structured to keep you educated and keep you thinking and keep you on the top of your game, because they ask questions about stuff that you hadn't dealt with before, and that's a good thing. And it keeps my ASE. I'm current on 11 ASE. Let's see. Did I? No, I don't think I renewed G1. That was something I had to have. That's just basic main as I was for a while. That's an easy test if any of you guys want to go take it, by the way. But this is an A6 pop test. I just figured I'd go ahead and give you a pop test, practice test, whatever. And we're going to work our way through this. And I'm trying to up my game and make these videos a little bit more interesting using this technology to build the slides. When using a DVOM voltmeter function to check for a voltage drop, the meter lead should be connected in which of the following ways? On the positive side of the circuit, across the component or the circuit to any non-conductive material, or in series with the circuit? That's question number 1, and we're going to go through the answers at the end, so you'll be able to tell me how you did at the end. Question number 2, which of the following is true regarding a parallel circuit? The highest resistance has the most current, the lowest resistance has the most current, the lowest resistance has higher voltage drop, the highest resistance has higher voltage drop. Okay, and there's an example of the circuit right here that I was talking about. Question number 3. When a digital meter is connected in parallel to the load device, which of the following defines the reading? Amperage reading, voltage drop, voltage spike, or pulse width? Question number 4. Which of the following tools can be used to quickly check a digital wheel speed sensor signal? A megameter, an RMS amp probe, a logic probe, or an AC voltmeter? Question number 5. You're charging a 12-volt wet cell battery on high charge, and while charging you notice the battery voltage is 15.9 volts. This means A, the battery should be replaced, B, you need to use a lower setting, C, you need to check the fluid level, D, the battery is being reconditioned. Question 6. To determine the full extent of the role of any vehicle electronic module, the best place to start is A, the owner's manual, rear index, B, description and operation, C, the wiring schematic page, or D, technical service bulletins. Here's question number 7. A customer states that when they apply the brakes, the instrument panel illumination lamps come on, even though the headlight switch is in the off position. What's the smartest first step? A, check the wiring schematic, B, replace the stop lamp switch, C, remove the rear bulbs and retest, or D, look for service bulletins. That thing is really pulling a lot of amps. Starters burned up 3 times in 3 weeks. Reman and new starters burn up the same way. The battery's been replaced twice. The battery to starter post voltage drop is 0.3 volts. This is with the starter spinning. Battery post to starter housing voltage drop is 0.4 volts. What now? You check the engine turning torque, replace the torque converter, B plus to solenoid S terminal volt drop, check starter drive alignment. And question 9. You're testing a charging system in a parking lot with no tools. You find a hacksaw blade lying in the grass. Somebody left there. Within 10 seconds, you know that the alternator field is energized. What did you do? Write your answer here. Question 10. With an assistant holding the key to the start position, the starter doesn't spin, but you read the voltage shown here. What does this mean? A, the battery is dead. B, you have a blown start fuse. C, bad solenoid contact. Or D, open ground circuit. Answers and discussion. This is the fun part. Alright, this one here, you're going to put it on the positive side of the circuit, just like you're seeing me connect that one. Voltage drop on the negative side of the circuit is just as important as you see me drawing it in there. Okay, so that's where you're always going to do it on the side of the circuit where you're checking the voltage drop. So you're always, it's always going to be, you're going to take your positive and connect it to the most positive side of the circuit, and your negative to the most negative side of the circuit. So this right here is basically measuring charging system voltage drop. If you're going for the alternator, now this one right here, you're basically measuring voltage drop on the starter circuit. But it's best, rather than going to the engine block, to go to the starter housing. That's the best place to do that. Which of the following is true regarding a parallel circuit? All right, watch that little video there. See the amps, see the ohms. All right, the one that's got the lowest resistance will have the most current. Voltage drop's going to be the same across a load unless there's another load in the series with that load. So if it's the only load in there, you're going to have the same voltage drop regardless of the resistance and all. And so when a digital multimeter is connected in parallel with a load device, you're measuring voltage drop. Now, there's your voltage drop measurement right there. See, you watch that little thing turn on. So you're going to have a little dab of voltage drop because there's a switch in series with the light. You notice this is 12 volts and this is 11.89. So this program that I use here, which is called LiveWire, factors in that there will be some voltage loss. Anywhere you have a connection or anywhere you have a switch, you're going to lose a little bit of voltage. It won't be very much. It shouldn't be very much, but you're going to lose some. And that's why this is actually 11.89 and this is 12 volts. So anyway, and of course I left the amps, you know, where they were. This is actually milliamps too, by the way, remember that. Which of the following tools can be used to quickly check a digital speed sensor signal? Logic probe. Now, not all digital speed sensors have got 3 wires. Some have 2 wires, such as on Dodge vans. It'll have 12 volts going to it, and it'll have a little square wave. And it's basically, you can measure that with a, the best thing to measure that with is a scope. But if you've got a logic probe, which, you know, will light up these little, hook it to positive and negative, you know, and it'll light up, red lights up when you touch power and green lights up when you touch ground. You can measure it with a logic probe and it'll wink that light on and off if you check your signal wire with a logic probe. That's typical. When I was working at the, you know, the Ford Jeep dealer where I was, there was, right after these electronic wheel speed sensors came out, there was a Jeep Grand Cherokee that came in there that had these electronic sensors on it. We had never seen those before. And so I changed, I found a code for a wheel speed sensor, and I just decided to go ahead and swap with another wheel. I put the wheel speed sensor from the one, you know, different wheel on that one, and the code moved with the sensor, so I knew it was a sensor. It was just a real quick thing I just came up with. And so after this was submitted for repair authorization, this knothead from Chrysler called me and says, exactly how did you determine that that wheel speed sensor was bad? Because he thought I'd measured it with a meter or something. And I said, I did an ABA swap with another wheel speed sensor from the opposite wheel. I could tell he was really going to jump all over me thinking I had tested it wrong. But you can't argue with an ABA swap. If you put the sensor somewhere else and the code follows it, bingo, you know. He says, oh, okay, well, thanks. That was the end of that. You're charging a 12-volt wet cell battery. Now, a completely sulfated or internally shorted cell, one cell takes almost no current. It'll push the full current through the remaining good cells and the voltage shoots up. Now, if you Google this, you may get other answers, but on all the OEM training I've received, and everything I've seen in other automotive training says the battery is sulfated and needs to be replaced. The first time I had been told that was in Jacksonville, Florida, at a Mazda school back in 1983. And ever since then, every school since then that I've run into, and every automotive training book that I've read says replace the battery if it's more than 15.6 volts after you've been charging it for 3 minutes. That's a part of, I think that's part of Sun's 3-minute battery test too, which has got a lot of other things you got to do. To determine the full extent of the role of any vehicle electronic module, go to the description and operation if you can find it. ALLDATA is pretty good about laying it out there where you can get to it. But sometimes it can be difficult to find because the OEM doesn't always publish it on every car. Of course, like I say, ALLDATA sorts all this stuff out. and puts that. I would probably have all data right now if I didn't mind paying a couple of $1,000s a year for it, but I don't work on cars anymore. Basically, I do this kind of stuff, and I do research, and I do this, write these, edit this stuff for carparts.com. So anyway, this one here says that whenever they apply the brakes, the panel illumination lamps come on, even though the headlight switched in the off position. When they mash the brake, those lights come on. Pull the rear bulbs out and test it again. If it doesn't happen, change the bulbs. You don't even need to know which one it is. Sometimes you can look at it and tell, but let's look at what that looks like. Alright, this is brake light filament, tail light filament, ground, tail light, and I got one of these old kind of bulbs to illustrate this. Alright, internal short right here will cause that to happen. And I have seen this on several occasions. See, I've talked about it in a previous video too. On the other side of the shop, I had a guy came over and told me he was having that problem. I said, pull the bulbs out of it and see what it does. It's real simple to do that. But anyway, there's you a nice little diagram about what that looks like here. Now this one here is the B plus to solenoid S terminal volt drop is the problem with this. Okay, so this is what that looks like. Alright, so let's say you got this one here from, and this is the trigger terminal that's going to operate the solenoid, and you're dropping enough voltage to where it doesn't slap this contactor in. It's supposed to slap it in really hard so that whenever, you know what a contactor does, a contactor, like on a hybrid or an electric vehicle or on an air conditioning unit or whatever, a contactor is basically got a big copper contact that's going to really suddenly slam against two posts. So if it goes slowly, it arcs and welds and stuff like that, and it begins to mess up the contacting surface, and it gets to where it starts to drop voltage in here, and then it gets to where there's not enough voltage in here, and then that low voltage is like trying to motor trying to run when it's locked up, because the voltage is not enough to spin it. It's enough to spin it, but not enough to spin it good and strong, and so it burns up starters. I mean, it flat sure does. So, testing a charging system, what you did was you held the hacksaw blade with the engine running up to the next to the rear alternator bearing cap, and you found out that it was magnetized. If the field is energized, that tells you the alternator is trying to put out, and you got a problem somewhere else. Okay, so that's it. Some of the smartest people I knew, but way back in the late 70s, there was a alternator. I mean, it was a shop, Spence Battery, down there in Port Arthur, Texas. You know, some of y'all might know, if you've ever been in that part of the country from eons ago, you'll remember that outfit. David Hughes was the guy that was the proprietor of it. But anyway, he had a machine shop, and he had a place where they built starters and stuff like that. And that was how they would test one. If they ever got one in there they were looking at to see if the alternator was putting out, first thing you wanted to know was is the field energized. If the field's energized, you know, then you've eliminated a whole bunch of stuff right there. That doesn't eliminate everything, but it eliminates a lot of stuff. It's kind of like measuring the using your diode check function on your meter to check the diodes in the alternator. I've talked about that on some other videos. You can find some on my YouTube channel about it. With an assistant holding the key to the start position, the starter doesn't spin, but you read the voltage shown here. It barely will spin. Now he's going to energize the starter, and we're going to see what our voltage drop is across the solenoid windings. Go for it. Golly, we're dropping 10. All right. It's horrible. That's absolutely horrible. And now you can actually run a screwdriver across the two big terminals, and it sort of spins, but it barely will. That means that voltage drop and that low voltage from it has burned the starter up. So we are got to get a starter, but the stupid parts house don't have a starter for an Impala in stock. Who in the world would have ever thought that? This is what's supposed to happen here whenever you energize that solenoid. That's supposed to slam this contact against those two, like I was talking about. This is what it looks like when it slams against there. You can see how if it moved slowly because it wasn't snapping in there fast enough, it would scorch these contacts and stuff. So anyway, you got a bad solenoid contact. That's what you got there. In other words, bad solenoid contact means the other problem I described earlier has caused this, and so you better look at both of those. Because if the starter keeps burning up, you need to make sure that you need to do a voltage drop test between the positive battery terminal and the S terminal on the solenoid and have somebody spin it over and see if you are dropping voltage there. If you're dropping significant voltage there, that'll be the reason your starter burns up. I've seen this before. All right, tell me how you scored, and I'll talk to you guys next week. I hope you hung around for now. We've only been here 15 and a half minutes, so I hope you made it all the way through it. Let's talk to you next week.